Okie dokie. All right, so we're still talking about integration techniques. Sometimes we need to tweak our integral so that we can make it fit a rule. It's possible. I don't know. It didn't tell me it was wrong. Yeah, it did.
Siri, how do you spell tweak?
There you go. Got it. Got it. Was in a hurry. I got it. You're welcome. Was in a hurry. Why is it in quotes?
Because it's not really a professional term.
I don't know if tweak is the official word, but it's what I'm using. Okay? Sometimes we have to adjust our integrand to fit a rule. Okay? So right now, can we take this integral?
They did e to the 1/2 x plus e squared, and you might be able to do something with that.
We would not be able to, because if we let u equal e to the x, then du is e to the x, and we don't have an extra e to the x.
Then replace e to the x with e to the 1/2 x, parentheses, squared.
I get that. However, in order for us to do that, you said 1/2 x, right?
Yeah.
In order to do that, we would have to let u equal e to the 1/2 x, which means du is 1/2 e to the 1/2 x dx, and there's no e to the 1/2 dx in our function. So that's not going to work.
So in other words, you couldn't use the arctan.
Correct.
That's how he says we have to tweak our function.
Yes. Now, if we let u equal the denominator, what is the u? E to the x dx, right? Okay, so that's not going to work either. Okay, now we have the possibility to add 0 or multiply by 1 to where we are not changing the value of our function, but we're changing how it looks. Okay, so what we can do in this case is we can add and subtract e to the x. We have essentially added 0. Do you agree? We have not changed the value of our function, we have just changed the way it looks. Now, with our function, we can separate it into two different fractions that we are adding or subtracting together. What would be a good way to split this up?
We have 1 over e to the x over 1 plus e to the x, or 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x.
Okay. We can split right there. There's a lot of e to the x's to keep track of, right? Okay, we can split our fraction in 2, which really means we have the integral of 1 dx minus the integral of e to the x over 1 plus e to the x dx. Now, right, well, first of all, the integral of dx minus, now this fraction here, we can let u equal our denominator, because now du, when it is e to the x dx, we actually have that in our fraction to substitute. So the antiderivative 1 over u is natural log of the absolute value of u. I went ahead and just replaced u all in the same step. Hope that's okay with everyone. Technically, you wouldn't need the absolute values because 1 plus e to the x is always positive. So in the back of the book, this probably would be in parentheses. If you write absolute values and they're not necessary, it's not going to be a big deal. Okay. Did you have a question?
No, you just answered it.
Okay, perfect. So here are a list of strategies that we can use. These are things that are just basic algebra concepts that you have learned over the course of the past 3 or 4 years. Okay, we can expand the numerator. That's what we just did. Well, no, that's not what we just did. Expand the numerator, like multiply things out. Okay, we can separate fractions. So if there's adding or subtracting in the numerator, you can split up the fractions. We can complete the square. This will be helpful, especially to force an integral to fit one of our inverse trig rules. Okay. Divide improper fractions. We already saw that technique yesterday. We just did this one, add or subtract terms in the numerator. Trig identities. Yay. And Pythagorean conjugates. Okay, if we have a 1 minus sign, multiplying by 1 plus sign can get us 1 minus sign squared, and that's Pythagorean identity that we can use.
Wait, can you give me an example of expanding the numerator? So is that like which one would that be? Like x plus 1, or no, x squared. Is that where you factor?
Well, opposite is factoring, like multiply out.
Oh, yeah. Okay, yeah, I understand that.
Okay. On page 511 in your book, there are examples of all of these if you ever need to reference. Okay.
On page 511.
What?
We can probably do it probably.
Mm-hmm. So, what I'm going to do is I'm going to put up an example, and you are going to text something to a number of what strategy you think would be best for the problem. Okay, so you have your list of strategies there. I'm going to show you a problem. I want you to think about which of these strategies would be best. Okay, so here's our problem. Go ahead and write it down. So we have the integral of x squared over x plus 1 dx. And this is what you're going to do. You're going to text this to 37607 to join, and then you can text me the answer to the pool.
Is it all caps?
Yeah, I don't know. So, working? One answer. And nobody knows.
Where's the problem?
Well, I see a theme. You all think we should divide in proper fractions. Josh, you get it figured out?
Yeah.
Okay, so all right, so let's go back to our example. Let's divide. Okay, now this, since our divisor is linear, you could use synthetic division if you wanted, okay, but I'm already committed to long division here. X times what is x squared? You multiply the divisor to x. Remember, we have to subtract. So we're left with negative x plus 0. X times what is negative x? X plus 1 times negative 1. We have to subtract. So our remainder is 1. So this becomes the integral of x minus 1 plus 1 over x plus 1. Is there a question? Okay. So, antiderivative of x, 1/2 x squared. Antiderivative of negative 1 is negative x, plus antiderivative of 1 over x plus 1 is a natural log. The absolute value of x. Of course, plus c. If it's improper, divide it. All right. Here's our next example. One over cosine of theta minus 1. Which would be best for this example? Uh-huh. Okay, all ideas are good ideas. Got question mark. Don't know what idea that is.
There's a good chance of sure. Sure, it gives you a subtle question mark.
Okay, trig identities is a good thing to think about. The identity theft. Good one. Josh, are you working on one there?
No.
Oh, so you're texting somebody else.
No. Texting another woman, another math teacher, there, Josh.
All right. Those of you who said trig identities, what trig identity is cosine of theta minus 1? It is not 1. So there is one thing we have to do before we can use a trig identity. So you are not wrong. We will need trig identities, but it is not going to be our first step.
Multiply it by 1. cosine of theta plus 1 over cosine of theta plus 1.
Okay, and what is that called? Well, I would call that a trig conjugate. Complex conjugate would be for complex numbers. You see what I'm saying?
Yeah.
These are conjugates, but with trig. What was your question, Bailey?
Nothing. I thought that you were doing the little no solution thing, but it was just a theta.
Oh, okay. So if we multiply by the conjugate, that forces, well, cosine of theta plus 1 is in the numerator. But in the denominator, we get cosine squared theta minus 1. Please tell me that you know what cosine squared minus 1 is.
Sine squared.
Let's go.
Calc for the win.
Hey, I taught you trig.
Would the sign be negative?
Would it?
Because cosine x plus cosine squared plus sine squared is equal to 1. So if you were to flip the 1 to the other side, that would give you the cosine minus 1. And then if you put the sign on the other side, that would give you a negative sign.
So do you agree it should be negative sine squared? Good catch. All right. So now, how is this helpful?
It's almost 50-50.
We can split the fraction, right? Because sine and cosine together make a pretty nice pair, right? For u substitution. But that plus 1 is kind of throwing us for a loop here. We can make this negative cosine of theta over sine squared theta, d theta, minus the integral of what is 1 over sine squared? And cosecant squared is not a bad integrand either, is it? What?
Some good golly.
How, oops, I forgot mine squared here. How are we going to go about this one right here? U equals sine of theta. Du is cosine theta d theta. So this is negative integral of 1 over u squared du. So this becomes a positive 1 over u. And this becomes minus a negative cotangent.
Why is it not negative 1 over sine?
What?
Neither are negative.
Because when we take the antiderivative of u to the negative 2, we make it u to the negative 1 multiplied by negative 1. Really, did we have to use u substitution?
What about the cosecant? Oh, that is not.
We wouldn't have had to use u substitution. If you saw it, you could have made this cosecant cotangent. Cosine over sine is cotangent, with an extra sign left over is cosecant. And then the antiderivative of cotangent cosecant is, but didn't hurt us to do some u substitution. It did? I'm sorry.
Okay.
All right. Example number 3. Let me know your thoughts. All ideas are good ideas. Unless you're sarcastic.
I got it, yeah. Something that just turned away.
Okay. Remember, I did give you a list of strategies.
Tell me what's going to be this way.
Oh, I just texted that to my mom.
Sorry. She's going to be really confused.
Hey, she's the math. She used to be a math teacher, so she'll get it.
She'll at least know what it means, right? So, basically, we know you've been using your phone for not just math class, right?
You can read.
I'm just teasing you, Sean. All right, so help me complete the square. So let's just take, I'm assuming you mean this, right? I'm going to write it as negative x squared plus 6x. Can we complete the square as is? Why not? Okay, so we need to factor out the negative. What completes our square? So we're going to add 9 and subtract 9, but this 9 is being multiplied to the negative 1.
Change plus 9.
Can we just put plus sign?
Yes, you can.
Sorry.
If you want to do it the easy way.
Okay, I just want you to remember, whatever we add, we need to subtract. But if there is something out here that is affecting the number we added, you have to multiply it before we subtract it. So, we have negative x minus 3, the quantity squared plus 9. Okay, so let's go back to our integral. Basically, this means we have the integral of 3 over the square root of 9 minus x minus 3 squared. Notice how I wrote that? Why did I write it like that? It looks like which rule? Arc sine. Okay. Now, I know I said, well, since this isn't just like x squared, okay, if we let u equal x minus 3, and what's true about du? dx. Okay, so luckily that x, it's not going to affect our integral too much. So I'm going to rewrite this as 3 times the integral of 1 over the square root of 3 squared minus u squared du.
So if it's linear, it's okay to just go ahead and follow it.
If it's linear, you can, well, if it's linear when there's only over the coefficient of 1. If that were 2x minus 3, then u substitution would be necessary. Okay. All right, so our rule. 3 times
1 over 3.
1 over a, arc sine of u over a, right? So we have arc sine of x minus 3 over 3. Plus
Wait 1 second.
Hmm.
Never mind. I got it. I said 1 second. Yeah, I figured it out.
Okay, all you needed was 1 second, right? Okay. Alright.
What?
Oh.
What?
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 What is this?
Okay, I don't think this one has a pull everywhere slide. Nope. This is our last example. Yay! Because then we need to talk about some throwback Thursdays. Average value. How do we find average value?
1 over the length of, 1 over 2.
Okay, so 1 over b minus a, so 3 minus 1.
Times the
Okay.
integral.
Times the integral from 1 to 3 of e to the 1 over t dt. Okay, thumbs down. We're not doing that anymore. No.
I just submitted my answer.
What did you submit? Because you didn't submit an answer.
I
And
did
Sean were
submit
texting each other.
What? No. Well, that after, but.
Okay,
I
ideas.
said, okay, I
There's
said,
one way.
I said up.
Ideas.
I said up smash the numerator. 'Cause
Ideas.
I feel like it was,
I hate you so much. You have E inverse of T, so can you drop it to the denominator? So that's 1 over T. So there, E to the negative T.
You have e to the t to the negative 1, not e to the negative t. Do you know what I'm saying?
Am I allowed to say t squared over e to the 1 over t parentheses to the negative first? Does that not be able to do something?
What would that be able to do?
Well,
Here's the deal, guys. Do you have more than one function? Okay? Always look for u substitution first. And if u substitution can't work, then go to a different method. Okay? If we were going to try u substitution, what should we let u equal?
e to the 1 over
T
t.
to the negative first.
Because then du is negative t to the negative second. Oh,
hey,
that's right
pretty
there.
good. I just thought about it.
Wait, where do you put in u? So,
E to the U.
So what we would have is negative 1/2 e to the u du.
oh, u. Okay, okay.
Okay. Let's go ahead and change our limits of integration. We'd be going from 1 to 1/3. How did I get those? We plugged our t's into here to get our u's. So we have negative 1/2 e to the u evaluated from 1 to 1/3. There we have it. That turned out to be a positive number.
Did you redefine the limits of integration?
Since this is 1, I plugged it in for t. 1 to the negative 1 is 1. 3 to the negative 1 is 1/3. So your homework is this, but guess what? You don't have to write it down because it's on your gold sheet that you all are keeping track of, right? Okay, good.
Hey-o.
Oh, that's not what I wanted.